We will talk about acoustics, connect that to IAQ, and why acoustic is a cornerstone within IAQ, how sound affects our health and well-being, as well as the productivity attached to that, the acoustic demands of today, and how we interpret them, and research and development looking forward. I'll promise you there are some really interesting topics and stuff in today's presentation. I would like to introduce two experts in this area, Tony Olsson, Acoustic Product Manager for Room Units, and Martin Ottersten, Sound Development Engineer handling air handling units. And those will be the one who guides you through the day. I will, as you said before, shoot in the questions, maybe do some comments as well. But over to you guys, and let's see where we end up.
Okay, good. Okay, thank you, Mikael. As Mikael said, today we're going to put the focus on acoustics out of an IEQ perspective. So kind of a high-level presentation, but we will dig down, and with Martin's help, we're going to actually dig down in a research project. So we have a presentation that I guess fits all. IEQ, let's start from beginning, and this is a recap for many of you, and for some of you that are listening in, this is new. Why is IEQ important? Well, first of all, we work with indoor climate for several reasons. On the left side, I will show you some circles, and we call them the soft aspect: health, well-being, building care, and special applications. And as an example, health, we take a look at the to secure the air quality. Well-being, we could look at thermic comfort or acoustic comfort, for example. Whilst building care could be ventilation to prevent mold issues. And if we look into special applications, as a museum in this example, there need to be a certain humidity level that needs to be kept in control. So that could be looked at as the soft side. Secondly, there's more of the hard aspect on the right side here. And the soft side very much affects the right side here, or the hard aspects. For example, in terms of performance level of people in the building, yes. Energy consumption of a building, or the economy for investment of a new building, or over lifetime using a building. The indoor climate has a great impact on all these factors, and it's usually a very good investment to take care of the soft aspects when designing an indoor climate system. With modern technology, it's possible to create solutions that maximizes both of these sides. Okay. IEQ as a concept then. IEQ stands for Indoor Environmental Quality. And in that aspect, we will look on the acoustic side. It's a concept that has received the increased attention the last decade, I would say, but even more the last few years. It takes a comprehensive view on indoor climate. The most important is, of course, again, the impact on health, our health, followed by well-being, our comfort, resulting in us being productive in a building. And you see 5 headlines here: air quality, humidity, thermal comfort, light, acoustics. I should mention that there is actually also a few more which are looking into interior design and the selection of colors that is connected to indoor environmental quality. However, today we put the focus on the acoustics. And I would like to do that by start off trying to see or categorize or mention what acoustic environmental quality actually is. Because looking into a building, in broad terms, we could say that acoustic environmental quality is creating a positive sound environment depending on the purpose of the building. For example, if we are designing an auditorio, aula or auditorio place where we should speak, or a classroom where students should listen, someone should speak, compared to a cell office or the hallway, for example, or the stairway, we will work differently with acoustics within the room or within the building. Normally, we would say it's to keep down the noise level, to have it as low as possible. Yes, in one sense that's true, but it's not only to reduce noise levels. We from ventilation business should be as quiet as possible, not to contribute to pollute the acoustic environment. However, talking broad about acoustics, we need to consider also sound level, frequency distribution, and reverberation time. That is parameters that is important as well. I will actually dig down deeper into those in a few slides, explaining what IEQ and acoustics is all about. But first, I would like to take us through sound affects our health and how it does that. There is, since 10 years back in time or 11 years back in time, World Health Organization released a report, a huge study with a lot of data combined 10 years from starting of 2000 to 2011, looking into acoustics and how that affects our health. And it turns out, if we look at the whole population in Europe and combine them into where we might have problems due to acoustics, and look at healthy years lost in Europe due to that, we could state, and evident from this research says that tinnitus, 20,000 years lost. Heart problems like cardiovascular disease and others, 60,000 years in Europe. And the one that got the most years out of the population is sleeping disorder. The most complaint was sleeping disorder due to acoustics, poor acoustic or noise pollution. Now, Martin, you also read this this paper or this World Health Organization. What I saw is that this is mainly looking into acoustic and environmental traffic sound coming from outside to inside. So it's a huge report.
Yeah.
But we also look inside the building, right? So therefore, I would like to state that it's not only the loudness of the sound, it's also the monotonous sound that affects us. And more precise, now we start looking into frequency spectrum of the sound. And we will talk a little bit more about just shortly.
Yeah.
So our sleep at night, we should be concerned about that, of course. So this report is done, and we will have some links in the end of this presentation, so you can find the research and read yourself if you like to. Moving into noise in the occupied zones, I will actually turn to this next slide, because noise sound affects our productivity. There is another research that I've been studying that claims, and now I'm going to be bold here to say that it claims that for every 1 decibel of noise eliminated in the academic environment, productivity increases by 0.7%. I can hardly believe this myself, but I read the study and I do understand that you need to also focus on from what level to what level and how do they actually measure productivity. My finding is that this statement is a little bit bold, but my finding is definitely lowering noise will increase productivity.
Yeah,
that's for sure. Then we can have a debate if 1 decibel will increase 0.7 or not. But let's move on.
Yeah.
In Europe, we are 80 million adults spending our times in office environments. More than that, we are 90 million children and young people in Europe who are spending their days in education rooms. I think it's our responsibility as an industry to always have acoustic in focus and not add to any acoustic pollution for these, because reducing noise increase productivity. It's a huge place here. That was a little bit about health and how that affects us. Now I would like to dig into a little bit of building certifications, or not a little bit. I did also look into a research that is conveying all certifications worldwide and looking only out of an acoustic perspective. I find this very interesting. So if we start with some headlines here: service noise, exterior noise, and so forth. In all international green building certifications, I will actually present them here as well so we can speak about them. In this case, there are 21 of them. Some are international certifications, green certifications. Some here is standards and a few national schemes. So this research or white paper actually that I was reading are looking into all of these just out of an acoustic perspective. What you find is these 8 subjects, and those is the one, if we point out IEQ and acoustics, if you have control over these, you will have a very nice acoustic climate indoor.
If I then may ask you, Tony, based on your experience, how often are those 8 considered in buildings?
All 8, never. Well, no, yeah. Of course, all subjects here are considered. Possibly the STI and sound masking we could put aside here, but the others definitely in new build. And good that you ask. I should emphasize that these standards and certification schemes are for new build only. So they are not looking at already buildings in the market, so to say. It's actually only one of these certifications that has all the subjects as credits that you can earn. Yeah. Just shortly, service noise, that's about mechanical service, such ventilation, hydraulic service, and electrical service that needs to be controlled. Exterior noise is the noise from outside to inside. Reverb time is basically a measure of time required for sound to fade out. Floor impact insulation is from a structure and sound coming from the space above, you could say. And acoustic separation is sound reduction between rooms. STI, it's not so well known, but it's used, and that is you're working with how well speech is perceived in a room. Sound masking is actually adding a sound to mask another sound. It's kind of common in open office spaces to mask out voices. And vibration, of course, like plumbing systems, mechanical equipment, noise, and such, we need to keep control over the vibration that spreads in a building. So why do I speak about this? Well, number one, these are the subjects for acoustics that are rated in a building. And if you have control over all these, you will have a very nice climate. Then my interest is, how do these certification schemes look at these compared to the rest of the credits you can get? Because it's, of course, not only acoustics. Well, first of all, the 2 most common that you find in nearly everyone is the service noise and the acoustic separation. And then it depends on which one of these that you are going for with your new build, which one of the subjects that you will need to follow. I guess many of you at least find a few names that you recognize of these certifications. I hope that is not too unclear. So what I would like to see here is the rating of acoustic in building certification, because when I did read this white paper, the rating of acoustics is on average 1 to 4% of the total value of the rating system. And working with acoustic, first of all, I got a little bit disappointed. But then I realized, okay, it's a lot of areas that you need to cover with credits when doing a building or certifying a building. So I had to dig down a little bit more and realize that the certifications that we were looking at, a few of them are looking just into sustainability or have the headline as a sustainability certification, whilst a few of them have the indoor environmental quality and the people in the building as their focus. So then I'm happy to see that those that have human beings as a focus rate acoustic quite high, actually, on all the credits you can have. And now I don't present here, but there's actually one of the Australian certification has 20% of the credits for acoustic, which is very high. So I would almost like to applaud Australia for that, thinking that that is good. So that is building certification or green building certifications. I know we are people from possibly whole Europe listening into this, but now I put the focus more onto Europe, because if you're not aiming for green building certification, there is also acoustics and national classifications. And how does this work? Well, in beginning of 90s, there started to come national classification schemes that based on the building regulation added some extra demands to acoustics, and in this case also specified the demand much clearer, so you knew what to head for when designing your building. In Europe today, there is about 10 countries that has schemes where you can get credits for your acoustic climates. It's almost like a energy rating, A, B, C. However, like with the green building ratings, the national schemes is not really any harmonization between any countries. So that would be something for Europe to work on, to harmonize acoustic demands, would make it easier for all of us in the industry. It's based on the regulations, the law, the building regulations, and on that we put higher demands. I'm going to give an example, because it's not 100% guaranteed that if you're following one of these schemes that all occupants will be satisfied with the acoustic climate. The lowest class, the C class, equals basically the regulatory requirements, and that one is designed to comfort approximately 80% of the occupants in a building. We know there will always be people that are more sensitive or that complains about acoustics for some reason. If you would like to go for a higher class to stamp your building with a B class, and this is one of the most normal class today, it's quite common that you go for B class, at least in Sweden. In different places in Europe, it's also common to have C, B, A, or they have similar kind of classes. B is a normal aim for building today, would satisfy most of the occupants. A is a very high standard. I have seldom seen an A demand, but sometimes we see the B demand, or not too seldom. And that would maybe mean something like, if sleeping disorder was one of the highest rated problems we had with the health aspect, it's also the highest demands in the national classification scheme. C class, as an example, would equal 30 dBA in a bedroom, because there we should find our rest, there we should be able to sleep. If you go for B class, then it would probably be 28 dBA. And A as a very high standard, then the demand in the bedroom with all installations on, so to say, would be 26 dBA. And that starts to be very quiet. Then it's quiet, I tell you.
But I'm a little bit curious in a way. Have you visited any building with class A demands?
Unfortunately, I have not. Martin, I know that you have actually been out doing some measurements at least.
Yeah, we were out on a Class A building.
Oh, you have? Okay.
Yeah, and it was 40 apartments where we did a measure. And to be able to measure this, we had to shut off the road. Because of the background noise was higher than this 26 dB. So it's 26 dB is really low.
It's a challenge because the envelope of the building needs to be well built in order to be able to measure it inside. So that's very interesting. Thank you. And we will actually dig down a little bit more. We will try today to let you listen to different sounds if we get it to work, hopefully. I will continue here by putting this one up. So as a baseline, we always have the building regulation. This is something that we have to follow. And those two I was speaking about here is optional. It's optional to go for higher class national schemes, but it starts to be common. It's optional to go for a building certifications, but we see it more and more. We see the LEED, the WELL, and the BREEAM buildings starting to come. But as a baseline, of course, the building regulations. And just short, how do we handle this throughout the building process? Well, I'm gonna read together with you here, but to start with and to get this to work correctly and to measure the 26 dBAs when you're in the building, we need the acoustic classification standard to be clear and verifiable. All the English word, let's keep it. Demands to the builders. That was a difficult word, sorry about that. Acoustic data should be available from suppliers, and consultants shall know the products and what risk there might be during building phases. Producer, supplier should have tested their products towards international and European standards, so there always will be correct calculated and designed specifications in the project. Two more. The entrepreneur shall have relevant mounting and installing instructions available, as well as if there is any risk moment in installing products. And those that are out doing the measurements to verify the controllers are supported by standardized measurement and calculation methods listed in the sound classification standard. If we manage to follow these 5 points, we will be very, very good off. And at least as far as I know in Sweden, this works pretty well. Now let's closing into the ventilation suppliers and acoustics and IEQ, because there is a challenge in the industry to actually also go with the product development for acoustic, or it's not a challenge to do development, but acoustics is also a challenge for us. Going from air handling unit on the left side here, in the middle we have 2 room products, and one of those I've been involved in a development project, and I know we had to send that product back a few times to development department just to pass the acoustic demands that are out in the market. Because for sure, this needs to deliver certain amount of air, but still be very, very quiet. And that's a challenge in the physical laws. In between, on the right side here, of course, there is attenuator silencers, and we develop them as well. And here more, we try to figure out how to keep the pressure drop as low as possible whilst having as high attenuation as possible. But the first one, the air handling unit, I would like you to actually now present a little bit about your project, because this is interesting, I think.
I hope so, but thank you. Yeah, let's talk about the air handling unit. Air handling unit is a sound source, of course, and both broadband and tonal noise. And as we can see here, we have fans, and the fans are actually produce tonal noise, and they produce the largest amount of tonal noise in the ventilation system, where the tonal noise has the largest effect on the indoor environmental quality, as we talked about. And sometimes it can actually be hard to get an idea on how the installed ventilation will sound like, and I will try to show you why. If we take a look at a fan spectrum of one typical or commonly used centrifugal fan, it will look like this. But the demands, at least in Sweden, are in octave band. And if we see the octave band for this fan, it looks like this. We can then see that we have two tones here, marked in green circle. And they are actually hidden or revealed from the octave band, so you cannot actually see that there is a tone. And if we go in more into deep of what these tones are, we can see that they are so-called blade passing frequency, and it's first harmonics, which is 2 times BPF. And what is blade pass frequency? The blade pass frequency is connected to the rotation speed and the number of blades in the fan. And here we see the equation where we have the RPM, which is the rotation speed, times N, which is the number of blades, and divided by 60. And then you get the frequency in hertz. This is commonly for air handling units between 100 and 1000 hertz, which is in the low frequency noise, which is hard to get rid of in the building. Small fans are normally between 500 and 1000 hertz, and larger fans are lower, 100 to 500 hertz. And this is due to the rotation speed of the fan. I'm also an industrial PhD student at Chalmers University of Technology in Gothenburg, where my project have been on this blade pass frequency and how it's created, or what's the source of this. And I will now try to get you through my work. And it's embarrassing to say that I can show you this by just showing you some figures. It took me 5 years to come here, but it's just some figures to show you my work.
I think it's good for us that it's just a few slides.
Yeah, or perhaps my figures are so perfect so I can explain it in just a few figures.
Yeah.
We take a look at the fan and a human, and when we start to rotate this fan, it will produce tonal noise. Of course, also broadband, but it's the tonal we are looking at here. If a human is exposed to tonal noise for a long term, you can get symptoms, as you described, Tony, before. But the more serious one is actually cardiac arrest. And this research was shown also in this World Health Organization paper research. So this is actually truth.
Yeah, we maybe should emphasize that this is over a very long period of time, so it's not really necessary to shut down any ventilation system. No. So it's not like a 2-day or 2-month exposure. It's a long exposure.
Very good, Tony.
Yeah.
But this is more effectful in my presentation.
Yeah, it is. It's a very it's nice.
Where do this tonal noise come from? If we take a look at this blade and we enlarge it, we see here a blade, and there is a gap here, which is between the rotating fan, the blade, and the stationary inlet duct on the left in this picture. This gap, air is flowing through this gap into the fan due to pressure differences. The pressure is higher outside the fan than inside the fan. We also see the blade leading edge, and I will come into blade leading edge soon. But if we take a look at what happens in this area, we see that when the velocity, which is really high in this gap region, interacts with the main flow, we get a lot of turbulence. The dark in this picture, the darker, the higher turbulence. And we take a look at these turbulent structures, now colored in blue. And we can see that the turbulent structures are interacting with the blade leading edge. As you can see in the picture, I hope, the blade leading edge, and there are turbulent structures. These interactions renders pressure fluctuations, and we know that pressure fluctuations are sound.
Yep.
So this interaction renders this tonal noise. So here we see the tonal noise level at this specific frequency. So we can see the amplitude of it. With this knowledge, we can now design a new fan where we can actually remove the turbulent structures, or we can remove the interaction between the turbulent structures and the blade leading edge, leading to, we can actually decrease or remove this tonal noise. We are now filing a patent for this. The sound characteristics. As I mentioned before, noise is really effective. Tonal noise is really effective of the sound characteristics. And today, demands regulate the noise in buildings, as you have talked about up to now. So I hope everyone remembers. I took here a normal value, which is 30 dBA with C class.
Yeah, that's a typical C class in a bedroom. Yeah. But it doesn't really tell whether you have low frequency or high frequencies. It's just a weighted value.
Yeah. And we will come into this, but that's the problem.
Yeah, that's the problem.
But how does 30 dBA sound?
And now we would like...
No, I will just explain where I have this sound from.
Sure.
Of course. Sure. I was a participant in a research project at the Swedish Research Institute, RISE. The project was about people and how they experience sound in buildings. So we had different air handling unit manufacturers installing their air handling units and into the ventilation system, and we recorded the sound in a specific room, and we recorded this. And all the sounds had to fulfill the 30 dBA demand, and now you will listen to these 3 settings. So now we have to shut off the mic.
Yeah, we try.
Were the problems?
We are not sure, but we hope that all of you heard some sound here, or what you actually should have heard is
they heard
3 different sounds. We heard 3 different sounds.
Yeah.
And the purpose of this, I guess, was that all these has the same volume.
Yeah.
The same level.
Yeah. According to the demand, they have the same level.
Yeah.
But they have, of course, really different sound characteristics.
Yeah.
And that's the problem. Because in the future, I hope that we can have some kind of sound characteristics into the demand, so we can classify tonal noise in some way.
Could we listen to them once more?
Of course, it's my favorite.
I would like to try.
Mic back. Yeah.
I must say, it's quite astonishing actually how different their sound.
Yeah. And
so 30 decibels sounds different.
Yeah.
Depending on tonal noise or not.
Yeah.
So so your project is very interesting.
For me, yes, and for the world, I hope.
So in the end, what you're actually saying is that we could create fan wheels that are much more, or at least perceives much more silent.
Yeah, the sound characteristics will be much better because we will cut this tonal noise that we showed in the spectrum. Yeah,
interesting.
but they are not quiet because they still have broadband noise.
Yeah,
we will cut off the tonal noise.
But then you can design the system differently, probably from sound characteristics.
Yeah, Tony, we can remove maybe silencers or.
It would be a dream if we could actually remove silencer and not stuffing up the system, or actually remove splitters maybe in a attenuator to keep the pressure drop down, because then we also could save energy by doing this. It would be excellent. And of course, to reach the very positive acoustic climate.
Yeah.
So it really are a win-win in the end, or? Or some backdrop there? Did I miss something?
No.
No, good.
That sounds good.
Yeah.
Yes, as a final slide, of course, software is also essential to be able to calculate acoustics. From internal calculations, dimensioning products, to external plugins and cloud solutions. So the data should always be easy available for consultants or those that need to calculate on acoustic, to have it as a base design, designing a building. And Mikael, with that said, it's actually the PowerPoint presentation. Prior to that, we just summarize. I guess we ask if.
I think we can open up for questions, and we have some actually already in the chat, and you can be able to write it in there more, of course. We had one question from talking about hotel room design, but I guess it could be whatever design actually. We're talking about air handling unit. We're talking about air coming back and forth, of course, to an air handling unit, and with the design, putting air into the room, you will have, for example, VAV dampers. You will have attenuators, etc.
Very nervous when I heard there was a lot of questions, but I think we did all right. As a summary, just to wrap this up, contribution to the noise within a building should always be in focus. It is, but still, it also should be in focus.
Yeah.
Acoustic, as we have spoken today, is an important part of the indoor environmental quality and our well-being. I think you know that by now. So by ending this, keep acoustic always part of the base of design early in a design process for a new building.
Great.
Good.
Thank you. And of course, thank you very much for listening. This was the 4th chapter in the Visualizing the Invisible chapter regarding Air Academy. All those webinars will be available on the website. Would also like to push for upcoming webinars during the fall. We will have the next webinars focusing on life cycle assessment and environmental product declaration. I think it will be worthwhile spending some minutes listening to that as well. It's a really hot topic in the industry. We will continue during the fall with circular economy, and we will also touch into what you actually just touched on, gender versus or including HVAC design, and see are there some trends or there's some research that we can find out.
Interesting.
So thanks again for listening. Hope you had a nice 1 hour presentation, and feel free to come back to us. Thank you.